Hello everyone, welcome to the demo for Shop Job T5 for ECMN 275. We're going to first talk about some of the characteristics about a delta system and things that we should already be familiar with. So we know that in a delta connected system, voltage is as constant from line to line and phase to phase, seeing how it is all the same. It's basically connected in a triangle configuration with the beginning and the end closing to make the delta. We use this in the voltage reference in talking about the usable voltage. One scenario where you might see a different available voltage is if you create what's known as a highlight delta. In our system, we're going to see 208 between line 1 and line 2, and then we also know that current coming into the transformer bank will be higher on the phase, higher on the line than it is on the phase by the square root of 3. The reason for this is because once it gets to the transformer's coils, it has more than one path back to the source, unlike the Y connection. So this would be the schematic for the shop job. Here you should notice that power is being brought in on the top side, line 1, line 2, line 3. And power is being brought into the beginning of each transformer, but also the end. So if we were on the first transformer with line 1 connected to H1 and line 2 essentially connected to H2, the rating of this transformer is 120/240 as noted on the shop job. It is a 1-to-1 ratio, so that means that 208 will split here and we will see 104 volts measured between H1 and H2 and 104 volts measured between H3 and H4. So that gives us the full 208. On the primary side, the delta is closed by the line 1 being connected to H1 as well as H4. On the secondary side, the delta is being closed between X4 and X1. Because we are generating power in a way or inducing voltage onto the secondary side, there is a chance that the polarity could be incorrect and that we could be producing a very, very high voltage that is dangerous to the transformer as well as the electrician working on it. So what we want to do here is a polarity test. You need to perform a polarity test before closing the delta. The polarity test takes place between the first X4 and the last X1 of the transformer bank. What are we checking for? We're checking to see if there is a real usable voltage. Sometimes you will see a harmonic voltage, which will appear in multiples of the supply frequency. For us, we have a 60 Hertz system. And if it is a real voltage and you connect those two wires together, so if you connect X4 and X1 together, and you measured 120 volts, let's say, that's essentially like placing line 1 to neutral. It would create a dead short, damaging the transformer and in some cases causing an explosion. Voltage measurements for this shop job, all voltage on the primary side will be 208 since it is a delta connected E line to E phase system, or E line equals E phase in this system. The secondary will appear to be slightly higher until we load the transformer with a load that will draw current. So again, that secondary side has compensating turns of winding so that once we do draw some current on that and the losses become more significant, eddy current losses, magnetostriction, so forth and so on, we will get down to that usable 208. But before that, you might see 215 or 220 with no load connected. Your current measurements, really we can only measure the current coming in on the line. Without being able to put our multimeter around the coils of wire on the transformer, we would then have to calculate how much current we would have on each phase. So if we had, for example, 3 amps on each line coming into the transformer, you would expect to see lower by 1.732, which actually brings it down to about 1.732 amps. Thanks for watching.